So today is kind of just more of the same from yesterday, but we're focusing specifically on arithmetic sequences. So those are the ones where you're adding something each time. And then on Monday we'll talk about geometric sequences. So those are the ones where you're multiplying by something each time. So it gives you your rules for how to define those recursively up here. So I'm going to highlight that so you've got it. So again, if it's a recursive function, that means that you're using the one before it to get to the next term. So that's what this is saying. You take what you have now, add whatever your common difference, that's what they say the D is, and then that'll give you your next term. So yeah, that's that. Are you all right? So again, if it's arithmetic, you're adding some number each time. So we're going to look at these three and decide if they are arithmetic or not. So the first one, it's already written out for you. What do you think? Are they adding some number each time? Yes, and what is that number? 2, so we would say that the common difference, D, is 2. Is that okay? Questions? Alrighty, so the next two are a little different just because they're not already written out for us. So we need to write out at least the first 3 terms. 3 or 4 is helpful, I think. So if we want to find the first term, we're going to do S sub 1. You're plugging in a 1 for n, so it is 3 times 1 plus 5, 8. Is that okay? So for our second term, we're going to do S sub 2. So 3 times 2 is what? 6 plus 5, 11. So then your third term, we're plugging in a 3, so 3 times 3 plus 5. And let's find the fourth one just for fun. So S sub 4, what's 3 times 4 plus 5? 17. So are they adding some number each time? Yes, and 3. So we could say yes, it's arithmetic, and that number, that common difference, is 3. They added 3 each time. Is that okay? Alright, so if we look over at the next one, to find our first term, again, we're going to plug in a 1 for n, so we'll do t sub 1. So 4 minus 1 gives you what? And then for the second term, we're going to do 4 minus 2, which is? And for the third term, we're doing 4 minus 3, which is? And for the fourth term, 0. We could keep going. We're not going to, mostly just because I've run out of room. So is this one arithmetic? Yes. What are they adding each time? So D equals negative 1. Is that okay? Yes, no, maybe? So when it's written in this form, where is your common difference? In front of what? The n. Yeah. So you'll see where that comes from in just a second when we go from this form. So when we simplify that a little bit, you come back to this, which is your common difference. So anywho, that's where that's coming from. So if you recognize that now, you don't have to find all the terms to tell what the common difference is if you're being asked that. Questions? Okay, cool. So that's how you define it recursively. And then down here, if you need to find the nth term of a sequence, there's kind of like a shortcut. So you don't have to find, if you want the 100th term, we don't have to find all 99 before it. You're going to use this formula instead. Okay? So this is a super important formula. I would highlight that one too. Or underline it, box it, something. So if we want to find the 41st term of this sequence, we're going to use this formula to help us. So we've got to know what a sub 1 is. 2, that's where you start. And we need to know D, that's your common difference. So what are they adding each time? 4. And we also need n, so what number or what term are we trying to find? So n is going to be 41 for us. Is that okay? So now we can plug into that formula that it gave us. So we're going to say a sub 41 equals, what was a sub 1? A sub 1 was what? 2. Plus parentheses n was 41 minus 1 times d, which was 4. Is that okay? So we'll do 40 minus 1, which is 40, times 4 gives you what? 160 plus 2, 162. So your 41st term is going to be 162. And that's a lot easier than having to add 41 times, right? Questions? Alright, cool. So the next one, they're giving you the 8th term. They're telling us that it's 75. So I'm going to write a sub 8 equals 75. They also give us the 20th term, and they tell us that it's 39. So a sub 20 is 39. We need to find the first term and the common difference. So the way that we're going to do that is kind of like a systems of equations, because we can take these and set up an equation like we did up here, but we're still going to have those variables in for our first term that we don't know, and for that common difference that we don't know yet either. Does that make sense? So if we were going to set this one up in this formula, we would say a sub 8, which was what? 75? Equals a sub 1, so whatever your first term was, plus n, which was 8, minus 1 times d, and we don't know what that common difference is yet, so we're going to leave that in there as well. Is that okay? I was trying to have it so you could see both formulas, but I'll just slide it up. It's probably going to be better anyway. So then we're going to do the same thing with our 20th term over here. So a sub 20 equals 39, so we're going to say 39 equals a sub 1, we still don't know what that is, plus it was n minus 1, so we'll say 20 minus 1 inside those parentheses, and you still don't know what the common difference is, so we're putting a d there as well. Are we okay with that? Alright, so we can simplify these a little bit, and then like I said, we're going to use like systems of equations to solve this. So when you're doing systems of equations, you can do graphing, substitution, and elimination. What do you think we're probably going to use here? Elimination. We'll get there eventually. So we've got 75 equals a sub 1 plus 70. And when you're doing elimination, you need one of your variables to cancel, right? It's going to be really easy to make that a sub 1 cancel. Do you agree? Because it's already the same in both of them. So I'm just going to multiply the entire bottom equation by a negative so that that will cancel out. Does that make sense? Multiply the entire bottom equation by negative 1 so that the a's will cancel out when we add our equations together. That's how elimination works. You need one of your variables to cancel out so that you only have one left over. Yeah, sorry. I forgot. So then when we add those together, we're doing 75 minus 39, and what do you get? 36. The a's cancel out. So then we just have 7d minus 19d, and what is that? Negative 12d. So then we can divide by negative 12 when we know what d is. Do you agree? Okay, so what does d equal? Negative 3. That okay? So yeah, now we just plug that d back into one of these equations. I just use the first one. It really doesn't matter. Either one will still get you there. So we've got 75 equals, we still don't know what our first term was, but we do know that we had 70 or 7 times negative 3, because we found that d was negative 3. Is that okay? So then 7 times negative 3 is negative 21. So we're going to have 75 equals a sub 1 minus 21. And we'll add that 21 over, so we're going to get what? A sub 1 equals 96. So our first term was 96. Our common difference was negative 3. And we're all done there. Is that okay? Questions there? I think the trickiest part on that was just like knowing what to do with the information they gave you. So, other than that, it's pretty straightforward, I feel. Anything we're not sure about, don't understand? Alrighty. So, still talking about the same sequence, we want to give a recursive formula for that. So the recursive formula was the very first one at the top of our page, so up here. So you've got to state what your first term is, and then we're going to write the rule based on this one. So I'm going to reference that, but you won't be able to see it on the board because we just don't have a reference for that. So our first term was what? 96. So you've got to include that anytime you're writing a recursive formula. You've got to have where you're starting. And then our rule is going to be a sub n equals. It has a sub n minus 1, which we will still use a sub n minus 1. And then it says plus d, so we know that d was negative 3. So we'll just say minus 3. And that's our recursive formula. That's all there is to it. Is that okay? All right. So then the next part, it wants us to find the nth term of the sequence. So that's this formula this time. So we're still going to have a sub n equals. You've got to have a sub 1, which again was 96, plus parentheses n minus 1 times d, which was negative 3. Is that okay? So we were just plugging into that formula that was further up on your page right here. So we can clean this up a little bit. We can distribute that negative 3. So we're going to have 96 minus 3n plus 3. Sub n over here. And then we can combine the 96 and the 3, and that's about it. So we'll have a sub n equals 99 minus 3n. And so now this rule looks a lot like the rules we had in 2 and 3 at the top of your page, right? And y'all remember how we said the number in front of n there was get your common difference once we found the sequence? Is that still true here? Yeah. So do we see how that all kind of comes together now? Maybe. Cool. Questions? Alrighty, we got 2 more, then we'll be done. So on the back, we're talking about the sum now of these. So you've got a bunch of formulas to do that. Again, you've got that sigma notation that we talked about yesterday. So you can use this. I think that these two are easier, so I typically use these instead of this one. But again, if any of them work, they'll get you the same way, or get you to the same answer either way. So for the first one here, we're going to use both of these formulas just to prove that they still get you to the same answer. And then after that, I don't care which one you use. So whichever you like better is fine. I typically just use this one because it's smaller, it's shorter, there's not much more to it. So, yeah, we're going to go ahead and do one. So we want to find the sum of the first n terms of this sequence. So we're going to use this formula first. So we're doing S sub n equals, we don't know like how many terms, so we still have n in there for all the n's. So we've got n over 2, and then we're going to have parentheses 2 times a sub n, and oh, I typed this wrong. This needs to be an a sub 1 right here. So change that to a 1 instead of an a sub n. And we need to find what a sub 1 is. So since we have a rule here, we can do that, right? So a sub 1, you plug it in as 8. And y'all, it's the same rule that we had on the front earlier, so you can just look at that. So a sub 1 is 8. What would a sub 2 be? 11. So what's our d? 3, which again, that number in front of n, right? So where it says 2 times a sub 1, we'll do 2 times 8 plus n minus 1 times d, which was 3. Is that all right? So we'll clean that up a little bit. We've got n over 2 outside still. And then 2 times 8 is going to give us what? 16. And then we'll distribute the 3, so 3n minus 3. And then we can combine the 16 and the 3. And that's as far as we're going to take it, because if we distribute that n over 2, it's just going to get a little bit messy. So we'll leave that out front, and inside we'll have 13 plus 3n. And that's as far as we're going to go. Questions? So that would be the sum of your first n terms for that sequence. So we're going to do the second formula this time. So we'll have S sub n equals n over 2. That's still out front. Then we had to do a sub 1, so that's the term you started with, which was 8, plus a sub n. So it said that a sub n was this rule, so we're putting that in there. So 3n plus 5. Because again, we don't know what that nth term is, so we can't plug a number in there. So we can add the 8 and 5. We'll have n over 2 still out front, then 13 plus 3n inside our parentheses, and it's the same thing we got last time. Is that okay? So again, I like the second formula better just because it's shorter. There's less involved there. I think it's a little bit easier, but yeah. So you get the same thing either way, so whichever one you want to use is fine. Questions? Alright, so for the next one, we are given this series, so we need to find the sum. So your first term was what? 60, and then we know that our a sub nth term, whatever n was 120, because that's where we ended. And then what about the d? Do we know that yet? 4, because they added 4 each time. So if you look back at the top, when we're trying to find the sum, both of these formulas need what? A sub 1, we have that. What else do they need? N, right? We got to know what n is. So we're going to solve for n using the formula over here, right? That tells you the nth term, and we know your first term, and we know what it equaled. We just don't know what n was. So we're going to use that to help us set up. So I'm going to copy that formula again, just so that we have it right where we are. So a sub 1 equals, or a sub n equals a sub 1 plus n minus 1 times d. So what was a sub n? 120, so we can say 120 equals, what was a sub 1? 60. And we don't know what n was, that's what we're trying to solve for, but we do know what d was, and that was 4. So we're going to solve for n. What should we do first? I would distribute that 4. You can minus the 60 over if you wanted. I'm just going to wait on that. So from there, again, like if you minus the 60 first, you could do that, or you can combine the 60 and the negative 4. However you want to get there is fine. We're just solving for n. I'm pretty confident y'all can do that on your own. So finish that, and we'll meet back when we get the answer for n. And we should end up with 16 there. Is that okay? Alright, so now that we know that n is 16, I'm going to add that to our list that we got going up here. And again, we can use either of these formulas, or you could even use that one if you wanted. I'm going to use this one. Is that okay with y'all? It's the easiest, so we'll just use that guy to find the sum. So we'll just say f sub n, which we know that n now is 16, so we could write f sub 16, because it's the sum of the first 16 terms. Equals 16 over 2, because we're doing n over 2. And then inside your parentheses, we're doing your first term plus your last term. So 60 plus 120. So that's going to be 8 times 180. And what does that give you? Questions? Alrighty, well that's all we got for y'all.